This is our senior design project. We are the assisted bowling device. I'm Andrew Mertz. I'm a mechanical engineer.
I'm Joe Cunningham. I'm also mechanical engineering.
Evan Carroll, also a mechanical engineer.
I'm Diego Hartsey. I was the electrical on the project.
We're doing this project to allow disabled individuals in wheelchairs with limited use of their arms to have a more involved bowling experience. Currently, there's just a simple ramp or a ramp that's directly attached to their wheelchair. Ours will be also directly attached. We'll also have a spinning mechanism, which is a critical part of most bowling experiences.
All right, so as far as our project goals go, one of the biggest things that was most important to us is to try and give them an experience that was similar to standard bowling. So we want exit speeds of the tube to be similar to that. We use gravity for that. We have a variety of spin options, so you can determine what way you want it to go. Ease of operation, of course. So simple layout, ability to attach to a variety of different powered wheelchairs as wide as we can possibly make it. And we're marketing it towards bowling alleys, not individuals.
So some of our initial design ideas for this, the first idea we had was to put motors with wheels at the base of the ramp. This way, when it exits the ramp, it already has the speed. It hits the wheels give it a burst of torque, and that gives it kind of the rotation that we're looking for, so that as it travels down the bowling lane, it's curving one way or the other. We wanted to use these T-slot connectors here to attach the motors. This allows for variation in where the motors are placed. Sort of variety would be a good thing. But kind of midway through the semester, and this was started last semester in the fall, we determined this was infeasible due to the time constraint of contact time between the ball and the wheels. We determined that the ball would be moving too quickly, that it wouldn't be in contact with the wheels long enough to rotation to have any sort of effective spin. So we moved on to a different design.
So with our final design, you can see up on the top, we've moved the motors to the top of the pipe. And the idea there is that the ball will rest on an idler. At the moment with our prototype, just two small aluminum rods. But this gives the wheels ample time to get the ball spinning to what we need it to spin at. And with this final design as well, the attachment mechanism that you can see, it's designed to be 3/4 inch EMT conduit. It's fairly cheap, not ridiculously heavy where it'll with mobility for the user, but heavy enough to give enough stability to the machine so that it doesn't rattle and jostle the person in the wheelchair itself. We want this, since we are marketing toward bowling alleys more than the consumer, we want this to be attachable to a wide range of wheelchairs. So, but there are two Velcro straps, one that will be across the back of the wheelchair and another that can attach to the armrest itself. This allows for wide variety of attachments, and should you need, with the EMT conduit being as modifiable as it is, you could add Velcro straps anywhere you would need for different people, or potentially any scenario you would need. And then for actually running the device, we have two main components of the controller. The controller itself on the right here that will be attached to the armrest of the wheelchair, as Joe is. And then on the left side, this is just our electronics housing. This is where all the actual computing happens. Our connectors that we have on here with the controller, most accessibility devices, buttons and any other controllers use 3.5mm headphone jacks as their connection point. So with that in mind, we have two female ports on the box to allow for, in the future, should someone have their own device that they would like to bring in, they can use that instead of the one provided by the bowling alley. We also have just some quick connectors shown in yellow for the battery for this right, and then the two motors on the left.
Yep. And electronics go on the inside of the controller. There's nothing too crazy on the inside. We're just using an ESP32, which are going to be controlling all of the LEDs as seen on the right. Those are going to indicate the various speed levels that we have. We have 3 on the left for left speed, 3 on the right for right speed, and that just obviously turns the motors off. There are two motors in the inside, one for each motor. They both run at the same level, so each motor should have plenty of current available, plenty of torque available to ensure that we're running as close to spec as we can.
All right, so for the sake of this semester, determined that a full-scale prototype was outside the scope of the project due to budget and time constraints. So we decided to build a scaled-down prototype. So as you can see here, the pipe is not nearly big enough as you would need for a full-size bowling ball. What this is capable of using is a duck pin bowling ball, which is roughly half the size of a standard bowling ball. And so we scaled down the pipe quite a bit so that the ball could fit through. We made it a straight pipe as well, just so we didn't have to deal with customized, curved pipes. And then just put it on stilts, figured out where the motors need to be, got that all attached, and it works.
One thing that we found during testing is with the ramp being a standard part, it is 6 inches, the ball is 4.5. It allows the ball to spin and rotate down, which does tend to decrease the accuracy and repeatability. One thing we want to do in the future is to make that more flush. So then when we were doing testing, we were able to get quite a bit of good data. Initially, we did carpet tests just outside of the shop. You can notice there is those wheels tend to vibrate quite a bit. The motor shafts weren't sitting well, and so we changed those in future testings, made them smaller, and added a thrust bearing on the end.
I hit it twice in a row that day, so we didn't miss every time.
Another thing to notice with the carpet is it has a lot more friction than a regular bowling alley, so you can really see the curve coming out instead of angle where it's looking directly at the wall and then it spins pretty drastically. We did get a chance to go to midway lanes and practice there.
So just before we get any further with this, we have a motor speed constant up there. That is just something that was part of the code. It is abstract, and the most important thing to remember is that it's just a level determiner thing. So 1,000 is low, 2,000 is medium, and 3,000 is high.
For low tests, you can see a little bit of spin there, allowing a little bit of turn. We're going for precision, not necessarily accuracy, as we weren't able to go for the pins using the small ball. They would interfere with their ball return mechanism. Here we have the medium. We're using a tape measure across to help us with our measurements. And then our high, which has a lot of spin in relation to the other two. And at this part of the bowling alley, it's been freshly oiled. Where we were traversing was all oil. We weren't able to go further and get to the unoiled section of the bowling alley. So that is taken into account in some of it.
Right, so the results from that testing we did. So top left here, this is just how we divided up the bowling lane. So all bowling lanes, they have those arrows marking just the sections of the lane. And so we based our results based on, we would run a series of trials with the same kind of position and the motors, and then see how often it would hit each quadrant. So with no spin, you see it's most often in quadrant 3 and 4 with some variation there. Also something to note here, since as Andrew mentioned, we couldn't test it actually hitting the pins. We were measuring it 42 feet from where it was launched. So it would rotate more if it was going all the way, but that's what we were able to do. But yeah, the main thing is the precision, how consistent it was getting to the same quadrant.
All right. So looking at our leftward curve, we have both our level 1, level 2, and level. And as you can see, our machine is in a different position now for the curvature. We had tried a couple, stayed in the center where it was for the no spin test, and with the amount of spin we get, it would end up a gutter ball every time. So the idea with this is more just to be repeatable than to get a specific from the center. But as you can see with our level 1 spin, kind of in the 4, 5, 6 range, with some smaller outliers at 3 and 7. Level 2 for the left came out quite a bit better. We had 6 in the third section, 3 and 2, and then 1 and 5. I had mentioned earlier, with the pipe being about 1.5 inches larger than the ball, when it would rotate a lot around the pipe as it came down, that would not only cause the machine to shift, but it would also just result in a pretty poor release at the end. And so that is a potential cause for some of these outliers. And our third level, 1, 2, and 3, those are the only sections we got, and came out fairly reliable on the higher setting.
All right, and for our right spin testing, we have some different sets of data. The level 1 spin testing, between 1 and 3, it was fairly modest in that regard. Level 2 was bang on pretty much every single time, which was very nice. And level 3, we were starting to definitely notice it cycling inside the pipe more and more, so that is something we're going to consider when we go on to do more future work.
We did perform an economic analysis of this. We took into account a manufacturing run over a 1-year period of time, producing 900 units, which is about 1/3 of the national bowling alleys in the United States. We use a 3% interest rate in our calculations, manufacturing, and we did a present worth analysis. First, we determined the cost per system, which is approximately $2,000, including all the parts, labor, overhead, and even marketing. And then we decided to sell these for around $3,000 a piece, as the bowling alley can afford a little bit more than a standard user. Using those numbers, you're able to calculate the present cost and present benefit, and therefore the present worth of about $900,000. This winter.
All right, and as far as future work that we're planning on doing, one of the biggest, or some of the big things that we had noticed is our motors. They are a brush design, which isn't inherently or anything, but ours in particular had some anomalies in the way they functioned. They spun faster in one way versus the other, and so just to divorce ourselves from that problem, we have decided to pivot towards brushless motors for future work and use motor drivers that allow us to be a little more precise in our control of them so that we can keep our speed more constant. We're going to be using a BMS just to ensure that we are adhering to all proper safety guidelines. Not everybody that's going to use this is going to be an electrical engineer, so we need to make sure that this is something that is going to be safe and repeatable every single time for every person that uses it. Speed feedback was discussed among us. It is things that we may potentially want to have if results deviate after the pipe adjustment. Instead of using a Cat5 cable, we were going to use a DB9 connector to have a completely removable controller. This thing. As of right now, the connector is permanently attached, but that can be changed. And we also plan to design a PCB if we were to do this in the future, just to reduce assembly time and make everything nice, tight, and integrated. And the best part is none of our parts are incredibly high cost, so this PCB could be made for very cheap.
Something else we would like to look into, as you can see in some of those demo videos, the motor shafts themselves, when running, had quite a bit of run out, and that's due to them only being connected at the motor itself and not having any external support. The motor shafts were made by Joe and I in collaboration with, or I guess in coordination with class. We had to have a couple different features on the shafts, so we had tapering, necking, and boring, and they worked out fairly well for what we would like, but in the future, if we were able to, we would like to significantly reduce that run out by potentially having either support on the other side to stabilize that or a second bearing just after the motor to give 2 points of contact outside of the ball that would help stabilize that pretty substantially.
Then one last thing we would want to change is implementing a release mechanism. For the sake of the prototype, it was entirely manual. For final product, we'd want that to be automated, with the push of a button, because we do have a working release button. It's just anything mechanical right now. So we would want to implement some sort of actuator system to, retract, allow the ball to fall down. So you don't need multiple people to run this. Any questions?
Open for questions.
And we'll have a demonstration after, if people are interested.
So how did you get the bowling alley to let you do this?
They're actually really accommodating. I
You
gave
just
them a
walked in
call,
and said, here's what we're doing.
I gave them a call, talked to the manager, and they were,
And they said, no problem, come on in.
yeah, they were really excited. They asked us a bunch of questions. It was right before their Ben's Bowling League, so they were really curious too. We had quite the crowd.
Were you wearing Mary swag?
One of us?
I think.
Maybe.
They knew you were from Umary, right?
Yeah. The one thing they didn't want is to have the ball go all the way in the back and go through the return system, because other than that, they were more than
Were
happy.
there other customers there seeing you as a curiosity?
Yep.
Thought it's kind of cool.
They thought we were reinventing the sport.
And that leads me to my one other question is there something in there that's going to require, one thing that's sort of worrying is what if there's no more skill involved for the guy? And it's in a sense where you push a couple buttons and this thing does all the work.
Sure.
And the disabled guy doesn't have that kind of skill level control stuff. Is there?
Well, an immediate thought to that is between each shot, you would need there is no PID or ball tracking that you would have to do in order to line your shot back up. So assuming that you would have to readjust in between shots, you'd have to get a pretty good feel for this level of spin is going to get me right about in this area. And so
That has to.
yeah, absolutely. Yeah.
Another thing too is the oil actually changes in a bowling alley over time. And so the wear would be different and the spin would therefore be different as the game continues.
And another thing on top of that is having Velcro attachments. Yeah, they're not going to be the most precise thing in the world. So there's a small amount of variability so that the guy isn't getting 300 points every game.
Yeah.
Dr. Carrico?
Related point, how do they aim? How do you aim?
You would adjust the wheelchair itself. It's attached to the side. If you strap it tight enough, it should, if ideally the final would be on caster wheels. So take or move the wheelchair, this would move with you and you could just line it up and it just be.
Oh, so that you could go back to without anybody helping you, you can get.
Right,
exactly.
The next.
Yeah.
Okay.
Yes, Alon.
Did you know this much about bowling prior to starting this project?
He did.
I did. I was bowling captain 2 years. So yeah,
Thing.
neither did I until high school.
Rodrigo?
So have you guys thought about making it a lower, so the person on the wheelchair can actually grab the ball and put it on? Because right now, they wouldn't be able to, you always need somebody, we assume that somebody's gonna be, but they can just call a transit, they would pick up at home, drop it there, so you wouldn't need somebody, so but then we would actually have to lower it, but then we'd change how fast the ball is moving because of potential energy, right?
We are under the assumption that the people using this machine have very limited upper arm mobility. So even grabbing a 8-10 pound ball, something like that, is out of the question at this point. We would assume that there would be either someone with them or potentially someone from the bowling alley to be able to help them with this, as they would also have pretty tough time just even getting the ball from the rack back up to the chair and then into the system, regardless of if it was lower or not.
Yeah, because like I assume that like the comparison that you guys did in the beginning, like those ones most likely is from a setup that like somebody on a wheelchair can just roll into the place, grab the ball, come back, put it like on their lap, and like so one person setup.
Yeah.
Like so like technically like they would be able to come grab and but like just to
So
just thinking about that.
for that image on the left, that is true. That is the case. What you can't see in the image on the right, it is cropped. This is someone who's operating the wheelchair with a mouse joystick as well. So almost no mobility. So yeah, this is under the assumption that there will be others to help them with this.
We have time for one more question.
Liz.
Building off this question, did you consider making a self-loading system for the device at all?
We have about the process. The ball return for a bowling alley isn't strictly standardized, and there's just a lot of concerns to be had with the return mechanism, because obviously right now the bowling ball has to go above the person's head. So if they're not positioned in exactly the right spot and the ball dispenses, there be safety concerns on that front. It was out of the scope of our project at the time, but could definitely be implemented in the future if there was a demand for it.
Thank you very much.